Okay, 2012 AMC problem. This is number 15 from the AMC12A and number 20 from the AMC10A. So we're getting into the really fun problems now. A 3 by 3 square is partitioned into 9 unit squares. Each unit square is painted either white or black, with each color being equally likely, chosen independently and at random. The square is then rotated 90 degrees clockwise about its center, and every white square in a position formerly occupied by a black square is painted black. The colors of all other squares are left unchanged. What is the probability that the grid is now entirely black? So we have a 3 by 3 grid, and this is just to help us see things. If you don't need to draw one, wonderful. But 3 by 3 grid, 9 squares, and there are basically 3 things we need to take care of. I need to take care of the center. Okay. I need to take care of the sides. So let's say edges. And I need to take care of the corners. I already used a C, so let's use I don't know, R for right angle. Okay, so first the center. The center is fixed, so it'll always be in the same spot. So unfortunately, we can never get that nice little thing where a white square will then be painted black, because it will always be where it is. So we have a 1/2 probability that we had it black to begin with. And that's the only way that we can get it black, because if it's not black to begin with, when we rotate this 90 degrees clockwise, it will still be white. Okay, now the edges. As we rotate clockwise, this edge goes here, this edge goes here, this edge goes here, and this edge goes here. And basically, the only way I can guarantee that we get a solid black figure is if either these two are both black, or these two are both black. And so there are 2 ways that this can happen, and the probability for each of these being black is 1/2 squared, except 1/2 for this one, 1/2 for that one. Okay. But unfortunately, if I do this, I actually overcount, because that counts when these 2 are black and these 2 aren't. It counts when these 2 are black and these 2 aren't. You know, I could have one white or both white. But it counts when all 4 are black twice. So I actually need to subtract off 1/2 to the 4th. And so let's do these calculations. So 1/2 squared is 1/4 times 2 is 1/2. 1/2 to the 4th is 1/16. And that gives me 7/16. And now I'm just going to make a quick argument that the right angles here, the corners, work exactly the same way, because we can see that they rotate, they shift around in exactly the same fashion. The only way to guarantee a solid black at the end is if either these 2 are black or if these 2 are black, and we'd have the same calculations, so this would be 7/16 as well. And that means that my overall probability is going to be 1/2 to require the center is black, multiplied by 7/16 to require that a pair of opposite edge squares are black, multiplied by 7/16 to require that a pair of opposite corners are black. And let's see, 7 times 7 is 49. Let's see, 16 is 2 to the 4th. 2 to the 8th should give me 256 times 2 is 512. And my answer is A, 49 out of 512.